The Longwall mining method. The contents are introduction, the applicability conditions, terminology, longwall phase, types of longwall mining methods, development, the factors affecting length of phase, extraction of coal, shearer, powered support and armored flexible conveyor. Introduction. In the method of secondary extraction, which is known as longwall mining, a relatively long mining phase, typically in the range of 100 to 300 meter, but it may be even longer, is created by driving a roadway at right angles between two roadways that form the sides of the longwall block, with one rib of this new roadway forming the longwall face. Once the longwall face equipment has been installed, coal can be extracted along the full length of the face in slices of a given width, referred to as web of coal. The modern longwall face is supported by hydraulically powered supports, and these supports are progressively moved across to support the newly extracted face as slices are taken, allowing the section where the coal had previously been excavated and supported to collapse, becoming a gouge. This process is repeated continuously, web by web, thus completely removing a rectangular block of coal. The length of the block depending on a number of factors. The introduction. This is a form of underground coal mining where a long wall of coal is mined in a single slice, typically 0.6 to 1 meter thick. The long wall panel, the block of coal that is being mined, is typically 3 to 4 kilometer long and the width ranging from 250 to 400 meter. As a cut or slice is taken along the length of the wall, the supports are collapsed, advanced closer to the face and re-engaged, allowing roof to cave behind. The applicability conditions. The longwall mining method was adopted in working when number 1, the seams are thick as 0.7 meter are worked, seams that are free from geological disturbances, the seams at depths greater than 400 meters, working in a contiguous seam. The inclination of the seam should be flat to 20 degree. The seams are to be mechanized for larger plant outputs. The applicability conditions. The seams are highly liable to spontaneous heating for better production and productivity. The weaker seams are soft seams, weak hanging walls and the foot walls. A gassy seam of any degree can be worked by the longwall mining method. The skilled manpower is essential. There are different terminologies to be understood for understanding the content of this course. Face, a long front from which the coal is worn. The tailgate, the roadway usually used for the supplies of material and return air. It is also known as the supply gate, main gate, the roadway used for the transport of coal out by and for intake of air. It is also known as the mother gate. The GOF line, the line at which the roof is intended to cave. Span, the width of the working from the GOF line supports to the face. Stable, a portion at the end of a face specially prepared to accommodate the machines to cut the face. Buttock, the portion of the face at its end from where the cutting starts. Face conveyor, the conveyor installed on the face. Then next is stage loader, the conveyor which receives the coal from the face conveyor for its transport out by. The face supports, the supports used on the face is called as face support. This particular figure explains the terminologies just I narrated to you. Long wall face. Long wall faces may be single unit or double unit faces. In the single unit face, the two gates are used for the transport of coal from the face. A conveyor serves the face. For the supply of the material, the respective gates at the flank of each face are used. Other gate is used for travelling of men, intake of air, etc. The diagram describes about it. The long wall face in the double unit face, the central gate is used for the transport of coal from both the faces. A common conveyor serves both the faces. For supply of the material, the respective gates at the flank of each face are used. This particular figure which is shown here describes the double unit face. The different types of long wall method. There are two types of long wall mining method. Number 1, long wall advancing method, and number 2, the long wall retreating method. First, let us discuss about the long wall advancing method. The face start point is close to the main headings, usually leaving a barrier pillar to protect them. Once the face equipment is installed, the extraction commences, working away from the main headings towards the block limit. Obviously, the main and the tail gates do not exist prior to the start of the extraction and have to be formed at each end of the face as mining progresses. The gate roads are effectively in the GOF and a false rib has to be installed on one side, usually by constructing a small pillar, sometimes using the stone cut from the roof in thin seams or using some type of cementitious material brought into the mine. Such gate roads tend to require a very heavy support system. The types of longwall under this one, that is the longwall advancing method, is explained in this particular figure. Here the main roadways of the mine, the tailgate, the gove, and the way in which the process is done is explained. In the longwall retreating method, the gate roads are first driven from the main headings to the block limits and then connected with a roadway to install the face equipment. The gate roads may be connected to another set of roadways at that point for ventilation, gas control purposes. Once the face equipment is installed, the production commences with the face retreating from the limit back towards the main headings, usually to finish at a position so that a barrier pillar is left to protect the latter headings. Under the type of longwall, we are further discussing that because the gate roads are long, it is normally necessary to drive at least 2, sometimes it may be even more, at each side of the block. That set of roadways which will be used for access onto the longwall and for coal clearances of the longwall are typically called the main gateway roadways, while the other roadway or set of roadways is typically referred as the tailgate roadways. The latter are used for primary access on occasions, but this is not generally the case. As the face retreats, the roadways forming the face ends are destroyed and become the part of the gove. The other roadways will remain open if adequately supported, and it is a common practice for one of the remaining roads at the main gate end, usually only one in any case, to become the tailgate of the next block. The gate road first working pillar then become the chain pillars between the blocks. This is a figure showing long wall retreating method, the gove, the main gate, the tailgate, and the longitudinal T's. In the long wall advancing system, the development drivages are comparatively less. All that is needed to keep the gate roads sufficiently advanced so that the face operation can proceed uninterrupted, but with the retreat mining development, drivages assume much greater importance. The following are the steps involved for the development of longwall face. Number 1, development of longwall face. Number 2, development of gate roads. Number 3, development of equipments. Next comes setting of support system. Once it is done, next is development of ventilation systems, and next availability of accessories. The factors affecting length of long wall face are: number 1, thickness of coal; number 2, dip of the strata; the continuity of coal seam; fourth, the presence of geological disturbances. Next come the required production rate, that is the rate at which the production is to be done. Next, daily advance rate, at which the advancement has to be there. Next, availability of equipments, ventilation, the capital available, and the strata control. The extraction of coal. It has been stated that a long wall advances by cutting the slices of the block. This is relatively simple for hand work faces and with a coal plow, but with mechanized long walls using shearers, the means of doing this is not as straightforward as it would at first appear, because of complexities of the equipments and in this process. To start, the cutting machine has to cut into the face after each slice is taken to line itself up to cut the next web. It is incapable of cutting at right angles to face, so has to be eased in at an angle. This is achieved by snaking the AFC on which the shearer travels, so that the cutter drum can cut a wedge shaped section of coal until the full depth of the web is attained. The extraction of coal. It is possible to cut a full web in one pass, and to do this in either direction, a process known as bidirectional or bi-die cutting. An alternative is to cut in one direction only, known as unidirectional or uni-die cutting, often actually cutting only part of the web height in one direction and then the remainder in the reverse direction. There are other more complicated processes involving only taking half the web width in one pass and the remaining on the return. At first glance, the bi-die cutting would appear to be quickest way to advance the, and frequently this is the case. However, there are advantages with the other processes relating to simplicity of operation. Steering the face equipment effect on the coal haulage systems, power requirements on the shearer, location of operators in relation to dust sources, etc., which can result in better productivity overall. The best system will often be different for different types of mines, particularly in different seam thickness and possibly even with different personnel. The extraction of coal, usual method of steering the face is to intentionally cut it at an angle other than a right angle to the gate roads. So, one end leads the other and the movement so caused counteracts the unintentional movement which is occurring. The required angle is created by cutting a fly cut, whereby the AFC is set up to a starting line set to the required angle. A wedge shaped web is thus cut. It may be necessary to take more than one fly cut to achieve the desired angle. Note that if too great an angle is present, this can have the same effect as the curvature on the face where the equipment may not reach the gate roads. Shearer. The Longwall shearer shears cut away the face of a coal seam in Longwall mining operations by mounting over an armored face conveyor, which is AFC. They are equipped with cutting drums positioned against the coal seam by ranging arms powered by hydraulic rams. They can weigh more than 100 tons, travel at a speed up to 30 meter per minute and cut away the slices of coal seams up to 100 centimeter thick. They can also be called shearer loaders. The shearer, a type of longwall shearers. The longwall shearers consist of large cutting drums mounted to a slim body. The cutting drums are used to cut a predetermined height of coal across the face of the coal seam on each pass. The shearer loader can be divided into three basic types. Number 1, the double ended ranging drum shearer, also termed as DERS, are the largest and most efficient type of shearer loader. The double ended machine includes two cutting drums mounted on ranging arms that can be positioned to accommodate a range of seam thicknesses. The second one is single ended ranging drum shearer, also called as in short SERS. It consists of a single cutting drum mounted to a single ranging arm. Typically, two SERs, that is the single ended ranging drum shearer, are used simultaneously to cut away the face of a coal seam. This particular picture shows the details of shearer, and in this you can very well understand the different components and the detailing. Cutting method of shearer, unidirectional cutting. In this method, the shearer cuts coal in one direction only. The return trip is for loading and cleaning the floor coal or traveling empty. During the return trip, the shearer can pick up the coal stumps left at the bottom as a result of drill jumpings during the cutting trip. Hence, the loading efficiency is very high for this method when the single ended ranging drum shearer is used. And if the mining height is larger than the drum diameter and the roof coal sticks to the roof, the forward trip cuts the top portion of the seam and the return trip cuts the bottom coal. If the roof coal does not stick to the roof, the forward trip is used to cut the bottom portion of the seam and the return trip used to cleaning the coal. Cutting method of shearer. The bidirectional cutting. In this method, the shearer cuts the coal in both the directions. Thus, a complete mining cycle is established both during the forward trip and the return trip. A complete mining cycle includes the extraction of the whole seam height followed by advance of both the conveyor and the powered supports. Under normal conditions, the leading drum cuts the upper 70% of the seam and the rear drum cuts the remaining bottom and cleans up the floor coal. Under special conditions, the leading drum may be used to cut the bottom coal while the rear drum cuts the upper coal seam, such as when parting is located. Then leading drum is used to undercut the parting of, otherwise the bit wear will be heavy and cutting resistance will be more. Powered support. The hydraulic powered roof supports are self advancing structures which are interconnected along the length of the longwall face. Each unit along the line is also connected to each part of the AFC. The function of the powered support are two: to control the strata deformation, fracture and movement around the coal face. Next, to maintain a safe and coal producing working environment, to limit the amount of roof to floor convergence, to prevent the broken rock from entering the work area, and to secure and advance all plant on the coal face including the roof support. Each support structure consists of a roof canopy connected to a base via a shield and laminate linkages. Side shields mounted to the canopy prevents the excessive debris falling onto the workspace during support advancement. The hydraulic legs of each type of support are inclined or splayed at an angle. This is to prevent the legs from buckling under the immense loads that they support. In Australia, the most common type of supports used are choke shield supports, the powered supports. Each support structure consists of a roof canopy connected to a base via a shield and laminate linkages. The side shields mounted to the canopy prevents excessive debris falling into the workspace during support advancement. The hydraulic legs of each type of support are inclined or splayed at an angle. This is to prevent the legs from buckling under the immense loads that they support. Powered supports. The hydraulic props and chokes of open circuit system can be retracted from their installed place by hydraulic pressure, and with the help of hydraulic ramps they can be placed back at the new place with the help of hydraulic pressures. The hydraulic pressure of hydraulic props and hydraulic ramps is supplied by a pump located near the face. In Longwall coal mines, where the wooden props or pegs are not used, the self-advancing or walking support is used, 4-leg and 6-leg canopy supports. Some companies use 2, 4 and 6 hydraulic prop mounted on a single hard base to support the roof. Such a group of hydraulic props can withstand heavy roof pressure. 6-leg hydraulic props are specially used for coal seams with thickness between 1450 to 2360 mm. 4-leg support is smaller than 6-leg support and is available for yield loads up to 310 tons, 590 tons and 728 tons. It works as canopy for armored chain conveyors and the coal cutting machines, shearer, etc. There is a gap of 70 to 150 mm between two units of these supports. This provides better ground control to the entire coal seams. These hydraulic props can be moved back and forth and installed at the right place with automation systems. This particular figure shows the powered supports. Armored flexible conveyor. In Longwall coal mining, the coal cut down by the shearer is transported by armored face chain conveyor, which is laid across the full face width to the head entry T junctions, where it is transferred to the entry belt conveyor through mobile stage loader. The armored face conveyor has large carrying capacity. It is structurally very strong, bendable and low in body height. It serves not only as a guide rail for the shearer, but also as the pivot for support advance. It transports the coal at a speed in excess of 1 meter per second. However, some face conveyors are running at a speed as high as 1.6 meter per second. Generally, the power and capacity of AFC are reflected by the motor size, pan width and chain size. The armored flexible conveyor components are drive head, the various pans like line pans, ram pans, connecting pans and adjusting pan. Next, the link chain. Next is the scraper or flight bars, tail end, double acting ram, which is used for both the support and conveyor advances. The auxiliary devices include face side ram plate, the gob side spill plate, the cable heading channel, the chain tensioning and conveyors anchorage systems. This on armored flexible conveyor figure.